Okay, so today we're going to talk about two-way tables. Two-way tables are basically going to be an alternative to Venn diagrams, for you to be able to calculate probabilities, especially when there's multiple things going on, okay? So basically what's going to end up happening is that these four boxes of a two-way table are going to kind of be the same idea as what you normally would have had inside the Venn diagram. Notice how there's four spaces in the Venn diagram, but it's going to be a little different, obviously, depending on like the setup of these situations. Now, you'll notice in this case it says sport utility vehicle, sports car. A lot of times this is going to be like complements of each other, maybe sport utility, not sport utility, but for right now I just want to show you just like a different application of the two-way table. But at a certain point what you're going to see is that stuff like, the overlap might end up being the part that goes in the overlap of the Venn diagram, and then, the not would go on the outside of the Venn diagram, and again, I'll show you that when we kind of put that all together. So you'll notice that these are two-way tables, that you basically have information again in those four boxes, and then everything along the edges is going to be the total. And in this case, this totals to 240, which means you surveyed 240 people, and this was the breakdown of male versus female versus SUV versus sports car, and so on and so forth. Okay? So let me show you how you can actually use this to be able to calculate amounts and probabilities. So we're going to start with just figuring out what section of the diagram or what boxes should we add together to answer some questions, and then eventually we'll get into probabilities, which remember could be like fractions, which come out to represent decimals between 0 and 1. So how many people responded to the survey? That's the total, okay? So if you sum the total down the right or you sum the total across the bottom, there are 240 total people who responded to this survey. I also want to point out, in addition to adding along the bottom or adding down the side, if you add these four boxes together, those also have to add up to 240, because that's the sum of all the people together in this situation. How many males responded to the survey? We'll go to the male column and go all the way to the right to its total. 60 male people responded to this particular survey. How many people chose an SUV? SUV, go to the bottom total along that column, and you can see 156 people said that they drove an SUV. How many females chose a sports car? Okay, so now you have to see when kind of like a column and a row overlaps. So I'm dealing with people who are female, but I specifically only want the people who were female and drove a sports car, so I have to look at where that column and that row line up together. So that tells me there are 45 individuals who responded to this survey that were females who chose a sports car. Okay. Notice that none of these were probabilities. Probabilities, again, have to be values between 0 and 1, or, fractional values that represent decimals between 0 and 1. These are just amounts. If I wanted to actually use this to now calculate a probability, I have to take the number of people that satisfy a situation and divide it by the total number of people who responded. So all my probabilities are going to be something over 240. What is the probability that if a random surveyor is selected, it is a female that chose a sports car? Okay, so somebody who is female and chose a sports car, remember that was 45 individuals, so 45 out of 240, that's the probability of choosing a female who wants a sports car out of everybody who is surveyed in this situation. Now, you're fine to leave your fraction as 45 over 240. You could reduce it if you want. If you want to see it as decimal to kind of get a better feel for the likelihood, this comes out to be 0.188, so roughly 19% of people who responded to this survey were females that chose a sports car. Okay, what is the probability that if a random surveyor is selected, it is a male that chooses an SUV? So I'm going to go back over here and I'm going to say, okay, how many males chose an SUV? You can see that that's 21 individuals. So 21 out of the total number of people who responded. That's actually fine if you want to leave it as 21 over 240, or if you wanted to turn this into a decimal, that was 0.088. So roughly 9% of people who responded to this survey were males that chose an SUV. Okay, now we're going to talk in the next couple of days about something called conditional probability, which means that instead of having your probability be out of everyone in the entire survey, it's only out of, a specific row or a specific column depending on the situation. This is an example of one that's going to come out to be a conditional probability. This is the key word that you see, given. given that a person is female. That means that our probability is only out of the females who responded to this particular survey. How many females responded to this particular survey? Okay, if you take a look, female, the total number of females was 180. So my probability this time is going to be out of 180. Out of those 180 female individuals, what is the probability that that person chose an SUV? So I'm not going to look at anything else in this table. I'm only going to look in the part that I highlighted yellow. Out of these 180 females, how many people chose an SUV? 135. So the answer would be 135 over 180. Now again, I know that I'm doing this not out of the 240 that I did all the other ones from because of this word given. That's going to tell you this is a conditional probability. It's conditional upon what part of the group we chose. Okay. As a decimal, this would come out to be 0.75, and then eventually what we would do with stuff like this is we would try to draw connections, like what inferences can we make? Oh, look, the probability that if somebody's a female, they chose an SUV, that was a pretty high probability, so that might be something that eventually, why would you use this in real life? Marketing executives would try to market to females then, SUVs, if that looks like that's the likelihood of what they would end up picking and things like that. All right. So if you take a look at the second example, it says health officials in Milwaukee, Wisconsin were concerned about teenagers with asthma. People with asthma often have difficulty with normal breathing. In a local research study, researchers collected data on the incidence of asthma among students enrolled in a Milwaukee public high school. So this, even though you didn't have to set this up, this is going to be more like what you're going to do when you set up a two-way table. Notice that you're going to end up having something where you have someone in the family that smokes and not someone. Okay, so you know what, maybe instead of using that symbol, I'll write the word not. That little squiggly was a symbol we used to use during geometry to represent not. You can see these two columns are going to be complements of each other, okay, and that's oftentimes what's going to end up happening. So you're going to have a student who has asthma, and you're going to have a student who does not have asthma. And again, you're going to see these are complements of each other. A lot of times this is the way it's going to set up. I would actually even go so far as to say we probably should reverse these two. So usually you would have S down the left column and not S. It's not going to really change anything, but that's normally how you would start setting things up. Okay, so why is this called a hypothetical 1,000 sample two-way table? So what the thing is that you didn't survey 1,000 people. You only have probabilities that are given to you. So you're going to say out of, let's say, a hypothetical 1,000 people, if the chances of them having asthma was 0.193, that means 193 of these 1,000 people have asthma. That's what that is for. Okay? And then it says, what are the chances that the probability a randomly selected student has at least one member in her family who reported to be smoking was 0.421. Okay, so that means 421 of these hypothetical 1,000 people had somebody in their family that smoked, so that would be 421. And then last but not least, it says the probability that a randomly selected student has at least one household member who smokes and has asthma is 0.120. Okay, so 120 people of these hypothetical 1,000 people have asthma and a member who smokes. So has asthma and a member who smokes, so that's where 120 would come into play. Okay, so now that you know that this box is 120 and 421, you can now use the idea that everything has to total along a row or a column to now fill in all the rest of the boxes. And then, like I said before with the Venn diagrams, that's the hard part. Then now you have everything you could fill in that you could actually use to get all the probabilities. So I would say, keep it easy. If you see that this adds up to 193 and this is 120, this means that there has to be 73 people who have asthma and no household member who smokes. If you know this is 1,000 and this is 193, do 1,000 minus 193 and you'll find out this comes out to be 807. 1,000 minus 421 comes out to be 579. Okay, so you can keep going down along each row or column until you get the correct total, okay, or use the total minus another box to get the value. So you would see 506 in here to make that add up properly, 301 in here to make that add up properly, and now you have all the information you need to be able to answer whatever question that you're trying to answer. Okay? I do want to point something out, by the way. So in this problem, we did a hypothetical 1,000 sample table because our decimals on our probabilities were to 3 decimal places or the 1,000th place. If my probabilities had only been 2 decimal places, then I probably would have been better off doing a 100 sample table. So I would have my total in the bottom right-hand corner be 100 instead of 1,000. And again, that just depends on are your probabilities given with 3 decimals like we have here, or 2 decimals like you might see in some other cases. Okay, so out of these hypothetical 1,000 people, how many people have asthma? So you would go to the asthma column or row or whatever, and you would see right here 193 students of these theoretical 1,000 would have asthma, if that was the correct probability. Total for students who do not have asthma, okay, if you take a look, asthma does not have asthma, and again, go to their total. That comes out to be 807. Again, remember, if you added those together, they would add up to be the total number of people that were theoretically responding to this survey. Total students with no household members who smoke. Okay, so no household members who smoke, their total would be 579. Okay, so now you want to get into doing actual probabilities with this. Okay, sorry, why is this doing this? Okay, so now you want to get into doing probabilities with, one more with the total. Total students who have at least one household member who smokes. Okay, at least one household member who smokes, their total was 421. Again, none of those were probabilities. That's why all of these are not values between 0 and 1. Now it's going to eventually get down here into actually doing probabilities. What are the chances that if you randomly select a student from these hypothetical 1,000 students, what are the chances that they have asthma and no household member who smokes? So let's look. How many students have asthma and no household member who smokes? Asthma, no household member who smokes. You can see that that's 73 people. So 73 out of our hypothetical 1,000 students, or 0.073 would be the probability in that situation. Again, you could leave it as the fraction, you could leave it as a decimal, it's kind of up to you. But I just want you to see now, if I want to now turn this into a probability, I have to make it into a fraction, and in this case, out of 1,000 people, okay? Because theoretically, I surveyed 1,000 people. Okay, what are the chances if I pick a random student that they don't have asthma and they have no one in their family that smokes? Okay, so no asthma, so let me use my highlighter, no asthma, and no one in their family who smokes, so you can see that would be 506. That would be the place where those two things overlap. So I would say, okay, 506 out of our theoretical 1,000 people, or 0.506 as a decimal, that's the chances that if I randomly pick a person, that is the chance that their family, that they have asthma and no household member who smokes. Okay, so when it comes to question number 3, you know what, I'm going to show you the Venn diagram because I want to show you the overlap between the two, but I actually really think in the long run the two-way table is going to be a better way for you to answer a lot of these questions. So it says Bethany surveyed students at her high school. She found 78% own a MacBook, 78 students. 57 of those own an iPad, 13 do not own a MacBook but own an iPad, and 9 own neither device. So let's start with a Venn diagram for that, and you'll notice this time that our Venn diagram is not just based on filling in probabilities. We're going to use it based on filling in the numbers of people that satisfy each thing. So remember the Venn diagram setup we have? It's going to be like 2 circles that overlap. One of those is representing people who have a MacBook. One of those is representing people who have an iPad. And then you're going to have some people that actually, satisfy both, and some that satisfy neither of them. Okay, so it says 78 students own a MacBook. Again, back to yesterday, if you remember, that's a little tricky for us because that would mean that the whole circle M should add up to 78, but we're not quite there yet because we don't know what proportion should be outside and what proportion should be in the overlap, so let's save that for a little bit later. Kind of same thing with the I one, like 57 of those students own an iPad. Again, I don't know what proportion goes outside of the overlap, inside of the overlap, so I'll come back to that in just a second. It says there are 13 students that do not own a MacBook but own an iPad. Okay, so own an iPad but no MacBook, that's 13 students that would fall in that I circle but not in the overlap. Well, now that, I know there's 57 students that own an iPad. Okay, so 57 minus 13 tells me that there are then 44 people in the overlap. If I knew that there were 78 that should own a MacBook, When I do 78 minus 44, that tells me that there should be 34 people who just own a MacBook. And then finally it says there are 9 students who did not own either device. So there are 9 students that go on the outside of that. Okay, so if I now have to figure out how many students did I survey altogether, if I add up 34 plus 44 plus 13 plus 9, it tells me that there were 100 students in total that were surveyed. Okay, that also tells me that what you're looking at here, 34, 44, 13, etc., those are actually the probabilities. 34%, 44%, 13%. You'd have to actually put it as 0.34 or 0.44 or 0.13 if you want to express it as a probability, but again, that's nice that these ones actually add up to be 100. Okay, so how do you then also now turn this into a two-way table? I want to show you overlaps between Venn diagram and two-way table. So for a two-way table, you're going to set this up where you're going to end up making 4 rows and 4 columns. So I'm going to make a rectangle, and I'm going to put 3 lines in the middle, and I'm going to put 3 lines across. Okay, I want to point out that the last column on the right and the last row on the bottom, those are going to be your totals. Top left-hand corner box is never going to be filled in. So you have to look at the 2 things that you're being given information about, and you're going to basically do 1 row or column as like itself, and then it's not self. So you have people who own a MacBook and people who do not own a MacBook. That little squiggly is going to represent not. You're going to have people who own an iPad, and you're going to have people who do not own an iPad. Okay? And eventually I'm going to show you how these boxes match up with parts of the Venn diagram. So if I start filling in the information provided, they told us that 78 students owned a MacBook. So I go to MacBook, I go to the total, and I can see that that would be 78. 57 of those students own an iPad. So I go to iPad, I go to the total for iPad, and I can fill in 57. Unlike the Venn diagram, I didn't have to wait to fill that in anywhere. I have a space for that already in the two-way table. And again, that might be one advantage of the two-way table over the Venn diagrams. It says 13 students do not own a MacBook but own an iPad. Okay, so no MacBook but own an iPad. No MacBook but own an iPad. That would be 13 students. And then 9 students do not own either device. So no MacBook, no iPad would be 9. And then just like we did in the previous problem, you basically add and like along each column to get all your totals to be right. So if I did like 57 minus 13, that should come out to be, 44, right? And then if I do 44 plus 34, that would come out to be 78. If I do 34 plus 9, that would be 43. 57 plus 43 adds up to be 100. 13 plus 9 is 22, adds up to be 100. And just to double check, 78 plus 22 is 100. So you can see all the rows and columns all add up correctly. So again, this is an advantage of the Venn diagram, of the two-way table, is that there's already spaces for every piece of information given. You don't have to be limited to just portions of circles. Now I want to show you how things line up, and I'm going to do this in kind of a color-coded way because I want you to see how the information in the Venn diagram and in the two-way table are actually the same. Okay, so when you hear and, like people who have a MacBook and an iPad, you think of the overlap section, right? Well, in my two-way table, you'll notice it's the same thing. Same exact number. MacBook and iPad is that overlap section. So a lot of times, and again, as long as you set up your columns the way that I did here, where you have something and not something, something and not something, this top left-hand corner is going to represent the overlap. Okay, let's talk about other sections of this, if you will. So use a different color. Your OR probability is normally this portion of your circle plus the overlap, plus this portion of your circle. Well, again, making sure you set up your two-way table properly, that is going to be the 34 plus the 44 plus the 13. Look at how those numbers are exactly the same. So those 3 sections represent those 3 portions of those circles. So you can see, again, things that are similar between the two-way table and the Venn diagram. And then finally, last but not least, I'll just do a different color here. Everything that was outside of those circles is everything that's in this bottom right-hand corner. So that's like your not probability. No iPad, no MacBook, and now again, everything is represented all together. Okay, so you can see, even though it's slightly different, everything here matches up with everything on the Venn diagram. I also want to point out, I'm going to get rid of some of these colors. Okay, I also want to point out that if you were to add up these 4 boxes, just like when you add up everything inside the sample space, this adds up to be, the same as the total. This also adds up to be the same as the total. So like where that can be helpful is that in the Venn diagram, if they told you like the chances of, getting something was, MacBook or iPad was, 78 or whatever it happens to be, you would have to have sat there and figured out, well, what parts the overlap and all that kind of stuff. Now what you could do is say, okay, if I know that the OR probability has to be these 3 added together, and then the complement to that would be nothing, everything on the outside, this is the last piece that should help me add up to be 100. And again, I'll show you that in an example in just a minute. So now that I have all this stuff filled in, now I can go further and fill out all the probabilities below. And like I said, I really do think the two-way table is going to end up being the easier version for you. Because like I said, there's a space for everything. Okay, you don't have to wait until you figure out what's in the overlap or what's on the outside or what's in one part and what's in another part. There's already a space for everything. Okay, if a student is selected at random from the 100 students who were surveyed, find the probability that the student owns an iPad. So we're doing probabilities for all of these. They should not just be amounts of people. So every single thing is going to be a number out of something, out of 100 or out of a specific column. We'll get there in a second. So what are the chances that somebody owns an iPad? Well, what's the total for iPads? 57 people owned an iPad out of our 100 people, so 57% or 0.57. Okay, again, you can leave it as 57 over 100. You don't have to do it as a percent. Does not own a MacBook. So no MacBook. That was 22 people. So out of 100, that would be 0.22. Owns an iPad and a MacBook. Owns an iPad and a MacBook. That's that like and probability, if you will. So that was 44 out of 100 or 0.44, 44%. Does not own an iPad and does not own a MacBook. Okay, so that's the not probability. That was 9 out of those 100 people, or 0.09. Owns an iPad or owns a MacBook. So basically you have to add up everybody who owns either one or both, and it's important that you don't count the overlap twice. So if you were doing this with the Venn diagram, again, you would have added up this portion of a circle, plus the middle, plus everything on the right-hand side. Now in the two-way table, you're going to add up everything in these 3 boxes right here. That's your OR probability, okay? And again, by only adding the 44 one time, you're not adding that overlapping section twice. So you have 34 people who just own a MacBook. You have 44 people who own both. You have 13 people who just own an iPad. So when you add those all together and you put that over 100, that's going to tell you, what is that? That should be 91 out of 100. Or 0.91, okay? And that's going to tell you what percent of people own an iPad or a MacBook. Okay. Let me do one more example. So go down to question number 3 from the homework that goes with this. It says, Philippe surveyed students in a high school. He found that 74% of students take a foreign language, 52% do not play a sport, 38% play a sport and take a foreign language. So I'm actually going to skip the Venn diagram for this. And I'm going to go right to a two-way table, and I'm actually going to suggest doing a 100 sample two-way table instead of a 1,000 because of the fact that I'm given percentages that are out of 100. So 0.74, 0.38, 0.52. Okay, so recap. How do you set up this two-way table? So you're going to make a box. You're going to put 3 lines down. You're going to put 3 lines across. Okay, the totals are going to go in the far right and across the bottom. Nothing goes in the top left-hand column, okay, or top left-hand corner. So let's look at the 2 main things we're focusing on, foreign languages and sports. So somebody either takes a foreign language or does not take a foreign language, plays a sport or does not play a sport. It doesn't actually matter if you put the foreign language down the left and sports across the top, as long as you set it up so it's something and not something, something, and not something, then everything else will kind of match up with the Venn diagram like we had mentioned before. And again, the advantage of the two-way table is you don't have to wait to fill in information. There's a spot for everything. 74% of students, so 74 out of our theoretical 100 people, take a foreign language. So 74 take a foreign language. 52 do not play a sport. Do not play a sport. So 52 do not play a sport. 38 students both play a sport and take a foreign language. Okay, so 38 students play a sport and take a foreign language. And so now you can just sit here and you can add and subtract down each column to be able to fill out all the different values that are left in the table. This is a 100 sample table, so all this should sum to be 100. So this would be 26 that don't take a foreign language. This would be 48 that play a sport. That means 10 of them have to be people who play a sport and don't play a foreign language. 16, and eventually if I do 74 minus 38, 36 would fit in this column. Okay, so pretty much like everything kind of falls into place once you start filling in the three pieces of information that are given. And then you can start actually using that to find any of these probabilities. How many people play a sport but don't take a probability of playing a sport but don't take a foreign language. Play a sport, don't take a foreign language, 10 out of 100. Don't take a foreign language or play a sport. 16 do neither, so 16 out of 100. Play a sport or takes a foreign language. So again, for the or probability, you want to think of adding these three boxes together. That's everybody who takes a foreign language and plays a sport, plays a sport, but doesn't take a foreign language. Okay, so you're not, and again, be careful not to add that overlap more than once. So if I add those together, let's see, that's 36 plus 38 plus 10 adds up to be 84 out of 100. Now this last one that I see right here, number 4, let's just save this for tomorrow. It says plays a sport given that they play a foreign language. But I just want to point out that word given, because that's going to be the game changer in tomorrow's lesson. Given that they take a foreign language means that you're only selecting out of the people who take a foreign language. How many people take a foreign language? 74. Of those 74 people, how many people play a sport? 38 of those people play a sport out of that 74. And that, again, that's going to be the big game changer in tomorrow's lesson. Okay, so again, set up the two-way table, fill in the information provided, and then make sure all the columns and rows add up together. You want to do a 100 sample table if things are given to you as percents or as only 2 decimal probabilities, and you want to do a hypothetical 1,000 sample table if things are given to you as 3 decimal probabilities, like you can see in